Hello everyone, I'm Paul and today we're solving problem 3494. Find the minimum amount of time to brew potions. Here it says this is medium, but this might be tricky. And there are different solutions for this, but here I want to show you what I think is the most intuitive, or at least for me. So let's start. We are given two integer arrays, skill and mana. So let's say we are given this, and each element in skill represents the skill of some wizard. Here we have 4 wizards, and we need to build 4 potions in this case. This amount of potions is given by the size of the array mana. So let's say we are building this potion. Each potion must pass through every wizard, and at each time we need to add this times the skill of each wizard. So first we start with this one. 5 times 1 is 5, so the time up to this moment is 5. Next we are here, and 5 times 5 is 25, plus 5 for the previous wizard is 30. When we are here, 5 times 2 is 10, plus 30 is 40. And when we are here, 5 times 4 is 20, plus 40, 60. Our job is down here. We need to return the minimum amount of time to brew all potions, 4 potions in this case. So here you can see the table, and the minimum amount of times to brew these 4 potions is 110. So we return 110. So for potion number 0, it's fine. We know that wizard 0 will be done by 5, wizard 1 will be done by 30, and so on. Now, for potion number 1, how do we know when wizard 0 will be done? Here it says this is 53, but how do we get this number? As I said before, there are different ways to solve this, but I think that this approach is very intuitive. Let's say for a moment that we only have one potion, potion number 1. And the start time here is 0, and wizard 0 will be done by 1. Why 1? Well, because we are at this element regarding mana. 1 times 1 is 1, so we start, meaning wizard 0 will be done by 1. Next, we are with this wizard, and 1 times 5 is 5, plus 1 is 6. So wizard 1 will be done by 6. Next, 1 times 2 is 2, plus 6 is 8. Next, 1 times 4 is 4, plus 8 is 12. So wizard 3 will be done by 12. If we only had one potion, it's fine to start at 0, but given that we have another potion before this one, we have to start at 5 with wizard 0. So here we should start at 5. Now we are with wizard 1, and we are starting at 1 with this wizard, with this potion. The thing is that this wizard ends with the previous potion at 30. So we should start at 30 minus 1. So we should wait 29 seconds to start with this wizard and this potion. With this wizard we are starting at 6. The thing is that this wizard is not done with potion 0 until 40. So we need to wait 40 minus 6, meaning 34. And finally here we can start at 60 minus 8, which is 52. And this is the key for this problem. This is the maximum start time for this potion. So we can add this to every value here. This is how we can get the minimum amount of time to build this potion. So 52 plus 1 is 53, 52 plus 6 is 58, 52 plus 8 is 60, and 52 plus 12 is 64. And as you can see, we are building the exact same table. So now we can repeat the process with this potion and then with this potion, and finally we return the last time, which is 110 for this input. So this is the entire approach, and with this in mind, let's go with the code. First, n is the length of skill, m is the length of mana, and we have an array to keep track of the times for the previous potion. We'll call this Brew. This is an array with 0 times n, and for Shay in range m, the maximum is initially 0 and the time is initially 0. This is the accumulated time for the current potion, and this is the maximum time we need to wait with any wizard to start with the current potion. So this is initially 0. And for I in range n, first we say t plus equal skill I times mana Shay, and every time previous at I is the current t. And here we need to update mx. This is the maximum between mx and previous I minus t. Okay, so we will only update this value if the previous value for the current wizard is greater than the accumulated time, meaning the accumulated time up to the last wizard for the current potion. Okay, and once we have the maximum, we can iterate every wizard again. So for k in range n, previous at k plus equal max. So we are adding the maximum difference to every wizard. And that's how we build the table. And finally, we can return the last value in the table, which is previous at -1. So this is the entire code. I think this is right. Now let's submit this and see if it works. This works and it's very efficient. Here time complexity will be big O of n times m, and space complexity big O of n. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.